my name is Hannah Samaniego. I was an intern through Spirit AeroSystems. I am actually a source reduction intern on the first year of a 2-year project funded by the EPA with Spirit, specifically focusing on solvent reduction. And so for those of you who aren't as familiar with Spirit, they are one of the world's largest first-tier aerostructures manufacturers with several locations throughout the US and globally. Wichita is actually their headquarters, so that's where I was. And that is an overview of their campus. Just to give you a little reference, that's where I was for a lot of it, for data collection and such. They have several customers, two of their biggest being Boeing and Airbus, and the Wichita facility primarily sells to Boeing. They supply structures such as fuselages, which are like the outside shell of an aircraft minus the wings. They supply pylons and nacelles, propulsion systems, wing structures, and various structures like that. The Wichita facility is actually about 12 million square footage. So due to size and time constraints, I had to significantly narrow the scope of my investigation. And so those are the two buildings I focused on. That smaller one on the left was my main focus. So for the project, as I said, I'm a source reduction intern. We had 4 main goals, one being to establish an internal advisory board to get their input and recommendations. The second being to overall reduce hazardous waste and emissions by 10% per airplane built. And so to do that, I looked at solvent reduction opportunities. I looked at high use solvent areas to try and reduce those hazardous waste and emissions. The project actually had 2 target solvents, some of their higher users, which was a Boeing material spec, as well as methyl propyl ketone. And I was able to find additional opportunities for reduction with isopropyl alcohol, their naphtha solvent, and a bar sol solvent. And in doing so, I found their fourth goal was training videos and case studies being published so other companies can gain from this information. And that will mostly be focused on in year 2. So I focused on the first 3 goals of the project this summer. And so some of the benefits I found were some process and technology improvements, as well as significant cost savings and the environmental health and safety improvements that come with that. Most of those solvents contain VOCs and HAPs, and this can form ground level ozone and get into stormwater runoff, as well as employee exposure. And so this reduction will increase human health and safety standards for the workers, as well as the surrounding environmental justice community. I narrowed it down to focus on the solvent hand wipe process that they have. And so their employees use solvent for the surface cleaning of aircraft parts in this process. They apply it to a cheesecloth rag, and then the rag is wiped on the parts. And this is used prior to parts joining or paint and primer application, sealant application, touch-up processes, and things like that. So the first building I kind of focused on, I wanted to see where the solvent originated from at their facility. And so that brought me to that smaller building. So Spirit takes 55-gallon solvent drums and decants them into smaller 16-ounce handheld squirt bottles. They do this through an electronic liquid filling machine. And then once they're in those bottles, they're separated out by type and order, and they're distributed throughout the facility. In finishing up this cycle, those used bottles, when they're empty, they're returned to that same area where that machine is, and they're refilled and reused, so you don't have to keep buying new bottles. In learning about this and going to that location, I identified 2 waste streams immediately. The first one being that the filling machine itself was generating substantial overflow solvent before the bottles were even making it to the various locations. And then that is disposed of as hazardous waste. It's collected under the machine. And then the second waste stream were the return bottles were not always, for various reasons, returned completely empty. So those are also disposed of as hazardous waste, also in that same area with the overflow waste. And so my first area of focus was the overflow waste. And so this is the machine in that building. Like I said, they take the 55-gallon solvent drums and it goes up to that solvent holding tank at the top. It's a typical gravity liquid filler. The bottles pass through that sensor. Once they have a certain count, the stop bars stop the bottles, and then the solvent is distributed through those fill heads. And then they move on after about 10 seconds. And so that machine distributes the 2 target solvents, the 11,7 and the MPK, as well as isopropyl alcohol and naphtha solvent. And so what I found in investigating this, oh, and there's that overflow area underneath there. So any solvent spilling over is collected and it's connected to a 55-gallon hazardous waste bin. And so what I found in investigating this is that this machine was installed before I was born, so not the most updated piece of equipment. And because of that, it's having chronic mechanical and electrical problems, most of these generating that overflow of virgin solvent. So just to briefly go over some of the maintenance problems and electrical problems that are happening. First and foremost, due to general inaccuracies and imprecisions of those fill heads, because they don't have nozzles currently attached to them, the solvent is not all making it into the bottle opening and it's bubbling out the top and just overflowing. Furthermore, the fill heads don't close completely when the bottles move on. So they're dripping solvent as the bottles move on. The bottles are being knocked over for various reasons. One of those being the conveyor belt speed will be variable. Some of this has to do with age, but also the solvent overflowing into the mechanism is messing with it. And so those bottles won't stop at the right place and they'll get knocked over. The sensor counter can have solvent in it as well, and that will also cause the bottles to stop at the wrong time and get knocked over. And then finally, that float in the overhead holding area won't always signify the solvent to stop being pumped, so it will just start spilling out and they'll have to manually stop that pump. Some additional overflow sources I wanted to point out that were not due to mechanical problems and due to processes that they go through right now. The first being a necessary process that they need to flush between the solvent types. They don't want to be mixing it when they go to fill the next solvent type. And so currently that's about 2.5 gallons per type that is distributed. And so that varies day to day for how many solvents they're distributing. They can do up to 4, so up to 3 times a day. They're losing that in flush volume. And then additionally, when they're finished filling the solvent for the day, they empty that overhead holding tank. And so right now that is an estimated 1.25 gallons at the end of each day. So I was able to measure the overflow using the hazardous waste container that the overflow area is connected to. I used a 55-gallon drum gauge and I measured the change in volume before the operator started the machine for the day and then after he was done dispensing the solvent. And I did that over the course of 6 days. And what I found was nearly 50 gallons of overflow in those 6 days, which is about 1 hazardous waste drum. I was able to take a ratio of the gallons dispensed through the machine to the overflow collected, and that ends up being about a 6.5% loss per gallon dispensed. So I got 2019 solvent usage, more of a typical production year pre-COVID. And so in a typical production year, this is about 5,200 gallons of overflow. And you have to account for the hazardous waste cost that comes with that, as well as the raw material being lost. This is about a $76,000 loss, as well as the VOCs and HAPS emissions that are coming off of that overflow solvent per year. So my recommendation for them was to get a replacement machine. I was able to speak with the vendor. I wasn't able to get an exact quote for the machine Spirit would actually use, but I was able to get a base quote that would just be an updated system. And so just taking out that overflow volume that is lost in typical production year due to the maintenance issues, not the flush volume That would be about a 63% reduction. And so this would total to be about $48,000 per year in annual savings. You would save on the emissions values, and you would reduce your hazardous waste by 3,300 gallons. Now, this does not include any labor costs for fixing the machine, maintenance costs for new parts, and the safety costs of being exposed to those chemicals, as well as if they are able to get a replacement machine that can reduce that flush volume, then this number would go up. While they're in that process of getting a machine quote, I recommended doing some trial and error, investigating, putting nozzles on the attachments to just try and get more precise distribution, decreasing that preset fill time to try and alleviate some of that overflow out the top of the bottle. And then in the meantime, if they could repurpose the waste for maintenance or parts washing and something that is not used on an aircraft part and doesn't have to be as clean. And so for the second project, I want to take us back to that second waste stream, those return bottles, and what I'm terming returned solvent waste. So like I said, for various reasons, they are returned, not always empty. You can see the top right is about half full, and I have seen completely full bottles being poured into that overflow area and thrown away as hazardous waste. And so I was able to, again, calculate with a 55-gallon drum gauge that volume that they got over 6 days. And I counted the bottles that were returned with about 10% or greater fill volume, just based on a visual estimate. And so what I found, unsurprisingly, is that the 11.7 solvent is being returned the most frequently, and this is their most used, so that was to be expected. What was unexpected is that when you look at the solvent type specifically, the isopropyl alcohol and water mixture, which is not distributed through the machine, but it's hand mixed there, so it is returned to them. That solvent type comes back more frequently with bottles that are greater than 10% total fill volume. So that was something interesting and definitely needs to be further looked into. And so I did the same ratio calculation, the total volume per gallon estimated to have been distributed under the assumption that each bottle that came back represented about 16 ounces of fill volume that went out. And so again, looking at a typical year in 2019, that would cost you a hazardous waste disposal cost as well as the raw material cost. And so this is about $40,000 per year with those emissions, those VOCs and HAPs from those solvents as well. Some recommended solutions for this, we got an advisory board meeting together. And so in just bringing this issue to light and brainstorming with them, we brainstormed increasing employee awareness through training videos, maybe through signs, just general increasing awareness, as well as possibly moving the waste collection sites when feasible, or the empty bottle collection sites. Currently, they're being returned right next to where the partially full bottles for reuse on the floor are. And so there's a possibility that sometimes just by accident, they get set on a table and get returned rather than in the partially full reusable site. And so estimated 25% reduction just from doing these activities would be about $10,000 per year in savings, and more, the more awareness you increase, that would further reduce this solvent waste being returned, as well as the emissions that you would reduce and about 700 gallons of hazardous waste reduced. For the third project, I looked at one of their paint booths and their process that uses some bulk solvent for paint gun cleaning. They use a Barsol solvent and MPK for their paint gun cleaning. The company that came out, we had vendors come out and tour that area and make recommendations. They recommended an automated paint gun cleaning system, either with aqueous or solvent cleaning solution. This needs to be further investigated to see what is most efficient and effective for the employees and what actually cleans the guns. This company also includes a monthly maintenance service where they come in and switch out the cleaning solution and just make sure the machine's working correctly. And so while this does need more research, it's an estimated 100% reduction on your raw materials because the company is not needing to buy that solvent for cleaning. The gun cleaning system where that comes from, they are supplying it, as well as they are switching out that hazardous waste. And so your hazardous waste cost is reduced. Where the research is needed is the hazardous emissions. The obvious recommendation is the aqueous cleaning solution. It would eliminate the VOCs and HAPs, but this might not be feasible. Additionally, the operators need to be willing and properly handling this equipment for it to work effectively. The fourth and final project I worked on was in that same area. They also use solvent for their line flushing for the paint booths. Those vendors recommended a solvent recycling system for this process, which would reduce the amount of raw material needed. While it's not directly a P2 project, P2 strategy, it still does generate significant cost savings for the company, and it would reduce their hazardous waste because it produces an alternative waste type rather than flammable liquid hazardous waste that is more unsafe. It would produce a solid puck form, which is not only cheaper, it's safer for everybody involved. So with that, there is an estimated 60 to 70% reduction, which would be about $118,000 in annual savings, about 5,200 gallons of hazardous waste reduced, and 6,900 gallons of raw material reduced that they would not need to purchase. Some final steps that I took, these are not projects that I was able to complete, but because this is a 2-year project, I picked target areas for the next intern and for the next steps of the project to move forward. So we looked at high use solvent areas, and they happen to correlate with high hazardous waste pickup sites in that larger building I circled at the beginning. And these were their 2 highest waste streams. This waste was collected over 3 or 4 days. And so it was sealant or sealant contaminated debris, and then that solvent debris, which is what we were looking at specifically how saturated the rags were, and things of that nature. So like I said, that sealant contaminated debris and solvent waste was the highest waste streams we found. Over 4 days, nearly 450 pounds of sealant and solvent waste. So there are definitely areas for improvement in those target areas. And so those are kind of some of the next steps. So in conclusion, we have established the advisory board, which was the first goal, and I was able to work on 4 projects and recommend 3 measurable solvent reduction projects, that overflow solvent reduction, as well as the reduction of the return solvent waste, and the line flushing solvent reduction. So in total, those 3 would equal $176,000 in savings annually. And then, like I said, those next steps are to focus in on those target areas where we collected the waste for further investigation. And then the second year of the project, that 4th goal, creating training videos and case studies. And so, are there any questions?